And so our first presentation will be on the climate projections for Minnesota. And that will be from Dr. Tracy Twine with the University of Minnesota. Dr. Twine, welcome to the committee. Please introduce yourself and proceed.
Thank you, Chair Long, and good morning to you and to members of the committee. Thank you for inviting me here today. I'm happy and excited to tell you about our recent project. My name is Dr. Tracy Twine. I'm a Minnesota. Okay, I'm going to share my screen. Are you see this?
We are. Your audio is cutting in and out a little bit, Dr. Twine.
As soon as I shared my screen. Okay, thank you, Chair Long. I will.
It may work better if they don't share.
Stop my video if you don't mind.
Well, I think the slides may be.
If I don't share the screen.
Important to the presentation. Yeah, let's see if we can. Let's see how we go with the presentation, then I'll let you know if we're having additional trouble hearing you.
Okay, thank you, Mr. Chair. Yes, please interrupt me, and I can move to another location if I need to. So good morning. I'm going to give you some results of a recent project where we have looked at projections to Minnesota's climate throughout the 21st century. We already know, based on our evidence, that Minnesota is getting warmer and wetter. As we can see, these just two examples of some recent floods from both the northwest side of the state near Fargo and the southeastern side of the state more recently. And there are floods in Duluth in the northeast, also some floods in the southwest. Central parts of the state, flooding is getting more frequent, temperatures are increasing, and so we want to take what we know and ask what's going to happen in the future. So far, warming has really been a winter phenomenon. This slide here is showing us from as far back on the record. On the left, we have annual average increases. So this is total temperature change in three sections of the state, kind of broken up arbitrarily to the north, the central, and the south. And you can see that they're pretty.
Dr. Twine, your audio is going out a little bit.
One direction. If we just look at average, let me move. All right, I apologize, Chair Long.
No problem.
If we break up this annual average temperature into the average low temperatures in winter and the average high temperatures that we have in summer, you can see that these trends are quite large in winter, where our low average temperatures in the north have increased by 7 degrees Fahrenheit over the period of this record, and have increased about 4.7 in the south. So in the summer highs, you can see we have some small warming in the north and central region, a little bit of a cooling in the south. So far, this has really been warming for us during winter. This is the observations that we have here. This record are consistent with what climate models, global climate models, are projecting as far as these trends to continue. So this is a slide from the recent sixth report of the IPCC. And so if we have a 2-degree global warming increase, this is showing North America temperature in winter and summer on the left, increases in precipitation in winter, summer on the right. And you can kind of, if you can picture where Minnesota is, there's kind of a 1 value increase at that location, and maybe a 1 value increase in precipitation. So what we want to do is take these projections and get finer resolution, our state is quite heterogeneous. We have a lot of biomes with forest to the north, agriculture in the central and the south, some grasslands, some urban areas. So we want some more information that can help our state make plans that are appropriate for various regions. So our question was, we know what's warming, it's getting wetter, but when are these rainfall events happening? When is it going to continue to get warmer? Where is this going to be? How often are these extreme events going to happen? So what our project has done is taken the global scale projections, which are accurate, as accurate as we can be, but we want some more information, some finer information. And so this is what our model will simulate if we look in our historic record from 1980 to 1999. So you can see, this is winter average, colder to the north, warmer to the south, but you can see that the heterogeneous landscape, and you can even pick out some lakes here in the state of looking what the model projects for the past. You might also notice from that global map that I showed you that we really didn't see any of our lakes. The global models have the Great Lakes represented, but they're too coarse of a scale to really represent, the more than 10,000 lakes that we have in the state. And they are very important, and they affect at least the climate close by the shoreline. And so we need to account for this too, and this is what my group is working on. What we did was use 8 of our global climate models and used a physical weather model to get some finer information at a 10 kilometer by 10 kilometer resolution across the state. And we made sure that when we ran it in the past, that any differences that we had with observations were corrected, and then we would project those corrections into the future. So what we find, if we just project to mid-century, about 2040 to 2060, with if we have some mitigation of greenhouse gas forcing, this is what we project for the winter. In the south, it's about a 2 degrees Fahrenheit increase, and in the north, about 3.5. You can see the variation with the scale here, but I've just decided to point out some of the main average areas, average values there in parts of the state. If we go to the end of the century, the bottom figure shows you if we just have business as usual and don't mitigate any of our greenhouse gases, we're projected maybe up to 12 degrees Fahrenheit warming up in that northwest quadrant. You can see kind of 10 degrees Fahrenheit in the middle. If we do tend to mitigate such that the globe follows a lesser forcing pathway, what we show up in the top right is an increased warming average winter temperature of 6 degrees Fahrenheit. Summer, where we didn't see much of a warming trend so far in Minnesota, it changes now. So this is a little bit concerning, such that if we go unmitigated, our average summer temperature is projected to increase by 7 degrees Fahrenheit. If we mitigate up in the upper right, we could reduce that increase to only a 4-degree Fahrenheit increase. Now, looking at precipitation, as we know, precipitation is quite variable across our state, and even across any region or metro area. It could rain in some location and not rain in another. It's a complex process to model. And so what you'll see with these gray lines is a lot of variability. And this is a statewide average, and this is all of our model runs. So the dark line you'll see there from January to December on the left is showing us when we average all of these results, what we get in terms of simulating the end of 20th century. On the right, what I'm pointing at there is this black line, which is the forecast, the projected value there. And then the dashed black line is the history. And so you can see that the model projects with pretty good certainty that will be wetter in every month except July, where it's pretty close there. So we have confidence that Minnesota will continue seeing wetter springs. No evidence to suggest that summer precipitation so far is going to vary that much. When we look across the state to see how it varies, what on the left is the historical run of precipitation, a drier northwest, a wetter southeast to the state. And with unmitigated emissions down at the lower right, the northern half really of the state is showing some increases in spring precipitation and up to about 1 inch per month of spring precipitation up in the north there. We also looked at snow depth changes. So back to winter, we've got a historical simulation of snow depth on the left. Unmitigated, we might have an average winter snow depth decrease of about 5 inches at the most there in the kind of the east central location of the state. Not much change to the north, which is great. And then if with the mitigated runs, a decrease in average snow depth of 3 inches. And then finally, looking at the number of days with snow cover. So we have our historical average there on the left. And on the right, this is where sort of in the middle of the state in the lower right, you might see, if I've got my laser pointer here. So right here, in the middle of the state is where we see the greatest decrease of days with snow cover. And that can be up to, maybe 50 or so. So 50 fewer days in the winter season on average. So what our study showed is that, we are consistent with what the global climate models project. We are just trying to get more detailed information across the state. We project that there would be continued warming in winter. We would see an increase in summer warming from what we've seen. Fewer days with snow on the ground. These changes should be mitigated. If there are reductions in greenhouse gas emissions, we will also need to adapt to these events that we're going to have. So what we have in the works is updating the data that I just showed you with the new projections from global climate models. We'll refine our output by accounting for all of the many lakes in the state and how they can influence the region around them. And we're working on how to help people use this data. I'm a nerdy scientist, and so I speak my own language of science and this data. It's nice if the projections that we have here could be useful to your constituents. So that's what we're working on now. These are the authors of the study, thanks to funding from LCCMR. And I thank you for your time, Mr. Chair.
Thank you so much, Dr. Twine.